Let's talk about the 9 most critical points of belt conveyor inspection according to Martin Engineering. Now, the reason I say that is because you might disagree with what might be a higher priority than the other, and that's great. That's fine. We just want to give you what we think might be some of the top 9 things to make sure you're looking at when you're doing a belt conveyor inspection or walking down your belt or looking for potential problems that could snowball into bigger problems. So that's kind of what we're sharing with you today is some of the things that as you're walking through your facility that you should be visibly watching for to prevent them from becoming bigger or more catastrophic problems. Number one, carry back. So you want to walk around those conveyors, take a look underneath the conveyor and look for any piles of material that's sticking to the belt after the discharge. That material, if wet, will stick to rolling components. Eventually, it'll fall off into piles under the conveyor, like you see here. It's pretty problematic because it causes a lot of belt tracking problems. As that carryback sticks to return rolls, it changes the diameter of that return roll, and that can cause that belt to wander or mistrack from side to side. The other big problem that we see with carryback is that it takes a lot of time and manpower to clean up the material that carries back from the ground. That's costly to the facility and that increases risk of injury because you're putting those workers in close proximity to the pinch points of a conveyor when they're cleaning underneath a conveyor belt. One of the things about carryback to understand is that it's really inexpensive to prevent. The return on investment of equipment to reduce carryback is very, very quick. It doesn't cost much to install belt scrapers, maintain belt scrapers, to reduce or eliminate that carryback. The cost of that equipment compared to the cost of the manpower to clean it up or to react to carryback, uh, huge, huge difference. Belt cleaners could pay for themselves in sometimes just a couple of days. Second thing you want to take a look at is you want to make sure that you're taking a quick look at your lagging on the drive pulley. This is one of those things that I think is often overlooked. A lot of facilities kind of treat that, they're a little dismissive to the importance of that lagging. If that lagging becomes uneven in wear, that will cause the belt to mistrack. It also will interfere with belt cleaning efforts, and that causes your carryback to go to increase. So if you're not familiar with lagging, what lagging's intent is to grip the belt at the drive pulley to make sure you've got that rubber on rubber friction to transfer the power from the motor to the belt and get that belt moving properly. Without proper lagging, that belt can slip, and that's unnecessary if that lagging's checked out periodically. Number 3 is belt damage. In our live instructor led in person class, we have enough time and enough discussion to identify and teach learners how to prevent 13 different types of belt damage. So the belt is one of the most expensive components on that conveyor. And it's rare that belts reach the full life of their expected service. And most facilities consider belts to wear with time. But what we try to instill in our teachings is that belts often aren't necessarily wearing, they might be being damaged. And if they're being damaged, that damage could be prevented, causing that belt to get fuller life, causing you to reduce the cost of replacing belts all the time. So I just grabbed a couple of examples of particular types of belt damage. But in our book, in our classes, in our online classes, we actually talk about 13 different types of belt damage. And you want to inspect that belt at least every couple of weeks for any particular type of belt damage that you might be able to prevent. Number 4, seized rollers. Seized rollers or rollers that aren't rolling properly are going to increase mistracking on the conveyor belt. They'll also increase the amount of drive power that's needed to run that conveyor belt. So you really want to take a look at rollers to make sure that they're rolling properly, doing what they're supposed to do. Um, it's a big form of premature equipment failure, and you can reduce costs of operation if you ensure that those rollers are not being built up with fugitive material, with dust, with spillage, and that'll keep those rollers lasting a lot longer. That brings us to our fifth point in the most critical points of conveyor inspection, and that's belt tracking. So I just got to pause and just let you look at this picture on the left. So that was just shared with me a few days ago. And what's happening on this picture on the left is this belt was mistracking so severely that the belt was bumping into some structure and cutting the belt. And as that belt was cut, it continued to mistrack and it wore that belt down, and all the edge that was cut off that belt was just piling up there on the edge of that chute wall. There's lots of devices out there that can tell you if and when the belt's mistracking. There's lots of devices out there that can prevent the belt from mistracking. But one of the biggest problems with belt mistracking is that there's just so many root causes, and most belts that mistrack might not have just one or two or three of those root cause problems going on. They probably have 8 or 9 or 15 different root cause problems of mistracking. So it's really a challenge for operators and maintenance staff to prevent that belt from mistracking because there's so many factors that can cause the belt to mistrack. So sometimes, many times, those belt tracking devices or those sensors are a great, great investment to prevent such a catastrophic problem like you see on the left. So you want to inspect for causes. You want to teach your staff what some of the things that they might be doing or some of the operational or equipment issues that might be happening that can cause the belt to mistrack so they know how to reduce some of those root cause problems. Um, if they can completely eliminate them, that's great, but that's a challenge. And then you also want to teach them, and this is something that we talk about in our book, in our online classes, as well as our live classes. It's really important to teach your staff that they should adjust low tension rollers first. There's more belt to roller contact on the low tension rolls, most commonly on the return rolls. Most conveyors are driven at the head pulley. That causes the return rolls to be the lower tension rolls. Because there's more belt to roller contact on those low tension rollers, there's more influence on the belt's trackability or steerability. And then that can help with belt tracking solutions. Number 6 is mechanical splices. So if you're vulcanizing your belts, good on you. That's a great practice. Continue to do that. If there's situations where you must use a mechanical splice, then you want to make sure you're taking a look at that splice. It's common knowledge at most facilities that if that mechanical splice sits above the surface of the belt, that splice will interfere with belt cleaners. For that reason, most facilities will back off their belt cleaners if they've got a high sitting mechanical splice. That's not the only problem with a poorly mechanically spliced belt. Another problem is what's shown in this picture on the left. What happens if you're using a mechanical splice, it will sometimes break the seal between the skirting and the belt in the load zone. And that's going to increase dust and spillage. So mechanical splices They're okay to use, they're acceptable, but our recommendation to prevent them from interfering with belt cleaners and to continue to seal dust and spillage properly at the load zone, that mechanical splice should be dressed and skived similar to what you see in the picture on the right. So in the picture on the right, what they've done is you can't see it, but they've skived away a little bit of top cover of the belt that lets that clip sit flush with the surface of the belt. So instead of having a clip that sits up like this, if this is my surface of the belt and this is my clip, what we would do if we skived the belt is we'd cut away some top cover and let that clip, which is going to be in the red ink, sit more flush with the surface of the belt. That's going to allow that clip to come through and not cause problems with the belt cleaners and not cause problems with your skirting efforts in the load zone. Most facilities that are using vulcanized splices kind of understand the value of them. They understand that they're stronger, and that it's not problematic with belt cleaners and sealing efforts. However, there are facilities that just don't want to spend the extra money to have a splice done, a vulcanized splice done, or they're adding belt or changing belts out often enough that it's just too expensive. But the biggest reason why most facilities use mechanical splices is just because they'll have a damage, an issue, and they'll need to add in some belt, and they don't have time to have a belt splicing company come on site and do that task. Most facilities have the capabilities of doing those mechanical splices themselves with their own maintenance crews, but vulcanizing usually has to be done by a company that specializes in that. They have the tools and they have the skills to do that. So that's typically why someone would mechanically splice over vulcanize. Number 7, off-center loading. Happens everywhere. Really challenging to prevent, but causes lots of problems. We've seen off-center loading so significant that it actually, the loading misses the belt and causes catastrophic problems of spillage. But off-center loading can be really problematic. It's really important to ensure that any vessel that's feeding the receiving belt, that receiving belt receives the load in the center. If it doesn't, it's going to cause that belt to push off to one side or to the other, and that's going to cause a belt tracking problem. So you really want to try to prevent off-center loading. What we would do in an example on the picture of the left is put some sort of deflector plate in there that kind of helps center that load. I want to draw something out here for you that might help you understand that. One of the things that we'll often see people doing, and it seems to work pretty well, is if this is my receiving belt and my cargo is coming down like this, what a lot of facilities do is they'll put a little kicker plate, and that kicker plate helps direct that material onto the belt. But one of the cool things that I've seen done with these kicker plates is I'm going to give you a different view looking down at this kicker plate. And what a lot of facilities have done, and we've done this as well for them, is they've put this kicker plate. Now, this is looking down at this kicker plate. So what, by cutting this V, the belt would travel in this direction, material would load coming down, it would impact that kicker plate right here, and then this V shape would let some of the material land in the center, and that can help center the load. It also prevents a particular form of belt damage. So number 8, dust and spillage at loading. So such a significant problem at so many facilities and can be quite the challenge to reduce. If you're unfamiliar with what's going on right now with the silica dust laws, MSHA has followed suit with OSHA, and they're really going to start in the next couple of years. This law is going to take into effect. In 2 years, it's going to take effect for metal on metal. In 1 year, it's going to take effect for coal, but they're reducing the amount of silica dust that miners can be exposed to. So it's going to be a real challenge for some facilities to get their dust at around conveyor belts under control. So some of the techniques that we use to control dust and spillage is we're first and foremost, we're not going to allow spillage or dust to exit at the tail pulley like this. So you can see in this photo, there's a ton of dust coming out the back end of this. And the reason for that is because they're trying to seal right here where there's just lots and lots of turbulence of air and lots of turbulence of material. It's a real challenge to seal right there because of all those increased air speeds. So what we would recommend is actually building your chute wall further back to a point closer to here and then sealing against the belt with your sealing system, running it along the sides, put some rubber flashing along the backside. Now, all this turbulence that you were dealing with, it's still happening, but it's contained with this skirting to rubber seal that's been created and supported by the chute wall that we would add. So if you can control dust, you've controlled spillage. So you really want to take close consideration to the small little things that help do that. And that's why I chose this picture. I wanted to show you some of those small things that are really important to controlling dust. So in this photograph, you can see that their idlers are spaced not too terribly far apart. These idlers look to be spaced maybe 12 inches apart. In some applications, that might be too far apart. Depends on how much air is going through that, depends on your material. But in some cases, we've had idlers stacked one right after another in order to support that belt properly. Now, if you look at the load zone prior to these two idlers, you see a cradle. And that's the best, most effective way to ensure that you've eliminated belt sag. You eliminate that belt sag, then that skirting can rust against a belt that's got a good foundation. And that's what lets that sealing system really do its job. So just a couple of really important things to take a look at when you're trying to reduce dust is you want to check very closely at your belt support. If your belt support is done properly, then your skirting is going to do what it can do. Number 9, you want to watch for what we call hammer rash on hoppers or chutes. So I grabbed a couple of really great pictures. I love these pictures because they're showing, they're identifying that workers have banged on the side of this vessel to promote material flow. So what happens is as your material changes, as the moisture increases, you can get material that builds up a little bit on the sides. It's a quick, common reaction from operators that if material starts to stick to the sides of a vessel, to just hit that side of that vessel with a hammer, and that'll dislodge that material from sticking. And that often solves the problem, but only momentarily, because it actually, over time, amplifies the problem. When you hit this vessel with material, like you clearly see on the left-hand side, that's going to create imperfection on the inside of that vessel. It's going to change that vessel from smooth to little bitty shelves that will actually make the problem worse and worse and worse. The inside of these hoppers or chutes or vessels need to be as smooth as possible to prevent material from sticking on them. When you change the sides of that by hammering on the outside, you lose that smoothness And that increases and increases and increases material from sticking on the sides. So it's a snowball effect. So you really want to inspect your vessels, chutes, hoppers. If they have hammer rash, you need to instruct your staff why that's problematic and find a different solution. Now, you might be asking yourself, well, what else can we do? We can't let that material pile up. I agree, but there are other solutions, particularly on small chutes. You could use what we call rotary vibration. For many, many years, Martin Engineering's been putting rotary vibration on chutes and hoppers to promote material flow. There's impacting vibration, but impacting vibration is really no different than hitting it with a hammer. It's a momentary solution, but it can cause that hammer rash over time. So rotary vibration is different. Rotary vibration doesn't actually impact the vessel. It shakes the entire vessel, and that promotes material flow. A couple other things you can do. You can line the inside of the chutes with a UHMW material. UHMW is a lot slicker than steel. That reduces material's likelihood to stick. Um, the other thing, and we're seeing this more and more and more and more, is to use air blasters or air cannons. So if you're not familiar with an air cannon or air blaster is, it would just be a tank of air, and we've done these for years to promote material flow, but it would be a round tank. I'm trying to draw this round, but I'm not doing a great job of it here for you. It's a round tank that sits out, and then it's got a valve on it, and that valve then pipes in, and it's mounted onto the vessel. And inside this tank, there's a volume of air. The valve gets a signal or can be manually operated. It says, hey, buddy, discharge your air. And that air discharges through that pipe into the vessel, into the material along the sides of the arm, and that will prevent or break up any material. So if you've not used those air blasters, they are a very common piece of equipment, but sometimes not used on hoppers and vessels as much as bigger storage vessels, but very, very effective on hoppers and chutes.